their phones all the time, just scrolling. So we thought, how can we take that to its logical conclusion? So what we've done here is what you're currently seeing is you're seeing Doom, and every single one of these little pixels is a TikTok. So, it's all rendering in real time. We've got Doom here, so can you move around a bit, shoot a bit, and it's all working in real time.
Alright, so basically we scraped the Doom color panel, and we tried to find like a corresponding TikTok for each color, and then when we render, we just take a sub-rectangle, find the corresponding color, and find the best matching TikTok. And that would produce a very large canvas of all the frames of TikTok to be rendered.
But we thought this still isn't enough doom scrolling for us, so we decided to also allow you to doom scroll while playing Doom.
So this is the interface where it's like TikTok. You can scroll to move. So scrolling up, you move backwards. You can scroll down to move forwards. You can like to shoot. You can turn. So you can, as much scrolling as you want.
Yeah, we remade the TikTok interface ourselves as well with the web app, and we've got that connected to the laptop.
No one's actually beating this. No one's actually beating the first level with this one.
As if we haven't actually done it on the laptop either.
It's moving.
So this is the texture map of TikToks that we've generated compared to the Doom palette. So we've got it copied over, and each copy is a different frame.
So yeah, if the game is static, or if any of it, this does run over anything, it's not necessarily just Doom, so you can, if you're interested, just watch your lectures without being bored. But yeah, if anything is static at any moment, you will also see that they do animate, so you have that stimulation. I think that's about it. Thank you very much.
Like games like Risk or Catan or Photopia, but this is basically our rendition or version of the game, where each node is actually an AWS EC2 instance. And if you actually get killed by another player, your city, which is the big blue dot there, dies, and you yourself get DDoSed.
So the way this works, when we join the game, we get a capital. Now, we join a game, the capital is a big EC2 instance. We give it, I think, a core, maybe a gig of memory. And we initialize all of the nodes around said capital. Initializing a node spawns its own instance, so each of these are its own server. And the way it's one of those games where we attack nodes, we get them and we use them to attack more things. We can kind of grow our empire and defeat our enemy. And so the way we attack a node is essentially sending a gigantic stream of data to each node, and then when each node gets overloaded, we consider it taken. So we DDoS at a massive scale by steadily taking more and more nodes until we amass more and more servers and more bandwidth, like we can see at the top. Until we get, we take so much that we get towards that enemy's capital. Now, this is a PvP game where any number of players can play. So when we take a player's capital, their laptop is also in this compute cluster. And so when we take a capital, because we can't DDoS the laptop because it would get disrupted by firewalls, so the laptop kind of conceptually sends HTTP requests to all of the enemy nodes to initiate WebSocket connections. And then all of the enemy nodes flood those WebSocket connections. So we get an actual DDoS on an actual player's laptop, and you only lose when your browser crashes.
Not violating AWS policy, just inspired by the events of US as a
But yeah, so hopefully, you can see that this is turned on for your sake. But once the enemy has captured all my nodes, my browser is now frozen. And with enough instances, this will actually crash my entire laptop. I really hope that doesn't do that now. My dissertation work is on here and I can still do that. Yeah, there we go. Pages unresponsive. And yeah, it's essentially doing like a bunch of computations. I think, yeah, what it's done is it just like floods the host laptop with like data. And yeah, it's doing some really heavy computation as well. And then it just like fills up the memory. And then it just crashes my browser. Yeah.
And then at some point, it will just say, oh snap.
I'll definitely.
Oh, wait. Oh, snap. There we go.
Great, thank you very much.
That .ds store file popping up in your Git repository. We don't put that in Git. And now we're going to show that we actually love those files. So we are effectively turning our Finder, which is our default file manager, into a web browser. So now I'm going to show two modes. The first one is the image mode. Now I am just opening up the Camhack file. Okay, now this is Finder. Yeah, you can go to documents, you can go back, and now it's Camhack. Right, so we just basically reverse engineered the .ds store because it's old formats, proprietary, I can't do anything about it. And use some old libraries to, yeah, and you can also click on the links. So for example, you want to join Discord, sure, we'll bring up script that helps you join Discord. Oh yeah, never mind, don't switch, please. Okay, now, in case that's not hacky enough, you can actually do that in text mode. So I'm pretty sure that Finder sounds like some browser in the 90s. At least to me, it does. So yeah, here's a text mode.
It's very
Everything is in text. Everything is just, everyone is just a single file, and still you can click on links. Sign up. Hopefully I'm not too late for Camhack25. Let's see how it goes. Yeah, so each time when it tries to render some image, it needs to like download all those colors and stuff like that. Oh, no, performance code. Okay, that's nice. And we can also do mathematical plotting. Right, that's that. And finally, if you hadn't been to the Camhack25 last night, you can just search in Finder. If you have Finder, why do you want to take a look? Yeah. And I think
Maybe to the fireworks.
so yeah, you can just pretty much do everything you want to find without installing Google. But the more interesting part about our project.
Right, yes. I mean, you know more about it, right? Since as DS Store is like a proprietary software, so Michael and Eric in particular had to actually try and reverse engineer and hack at how we're actually going to manipulate it. Michael, do you want to go back and talk a little bit more about it?
Yeah, so it's a binary format. So yeah, we did compare to different DS Store files, see how the icon moves and how the colors and the label places work. But yeah, and then more interesting of 20 seconds is our Git comment history. Yes, and we did manage to merge everything in the end. We got 5 people working on 7 different branches in parallel. But yeah, that's it. It's just difficult to do this in the end. Thank you, everyone.
For simulating neural networks and ML algorithms. So essentially, we made a digit classifier that is trained using Clash Royale battles. And the outcome of the battle determines the digit that gets classified. So, choose a digit, any digit between 0 and 4, and I'll draw it. 7. 3, okay. 7 is not between 0 and 4, but no. Alright, 3. Alright. Now, it will run 5 parallel instances of Clash Royale. It's an open source project, so it's not actually Clash Royale, because we otherwise can't simulate it. So, from left to right, 0, 1, 2, 3, 4. Whichever one wins fastest is the digit that gets classified. Okay, well, so as you can see, this is the third one. Looks like it's something is about to hit the, looks like the encoded path is locked onto the tower, and looks like digit 3 is the one that gets classified. So, as you can see, it works very well. So, you can talk a bit more about like how the thing works.
Yeah, so how it works is for the red king, so the red king, the troops are the same for every image, but for each of the digits, it's different. And for the blue king, it's the same for every digit, but it's different for every image. So we need some sort of encoding to go from an image to a set of country troops. And so how do we do that? Well, we use a variety of techniques, so mainly just like black box optimizations. For example, we tried simultaneous annealing, we tried dual annealing, we tried TPE, we tried some like engineering algorithms. But in the end, we took the image and then we divide it into basically like 4 times 4 blocks and like 7 by 7 blocks. It's from MNIST, so like handwritten digits data set. And so like originally it's K by K8. And so for each image we convert it into self-control troops, and that's for the blue king.
Yeah, so for the red king's troops are the actual parameters that are trained by the neural network. This is done for using very, not a neural network, but it's like a black box optimization. But it's done for using very fast simulation. Probably each battle can be simulated in like probably like 10 milliseconds or like 15 milliseconds or something. So that's why we use the open source project instead of like the actual Flash Rail API.
Yeah, and that's also like proprietary, so it doesn't exist on the internet, like we're looking for it. And we'll probably get banned if you use like BlueStacks or some else, or like some other API. So we didn't do that.
Yeah, play Clash Royale, guys. It's good for your health.
I'd like a show of hands.
Hold on.
Excellent. So our project started with the theory, what if you could represent meth on a map of Albuquerque? And can we get a name? So let's just find it. So yeah, this is the chemical diagram for meth on a map of Albuquerque. So what our project basically does is, if we show the UI now. Right. Somebody, I need the name of a molecule. So that could be a drug, just a general molecule. If someone could put their hand up and give me one. Excellent.
C6H12O6.
Does that have just like a name, like something acid or
Glucose.
glucose? You can tell what it is. So we can search for glucose. We just use an API to get some different search results, and so that's going to be calculating. So we'll see that towards the end. So I was in charge of the UI, and it's kind of rustic, we'll say. And then the back end is with a Python script. So so Eve is going to take us through some of our examples.
Okay, so we try basically the programming basically aligns up the chemical structure shape with the sort of best fitting rows and how we can get more in, for example, Camhack, so we want to get a more accurate as possible. And the different coloured nodes that you see on the graph represent the different types of atoms in the molecule. So for example, I think red was oxygen, blue was nitrogen, white is hydrogen, green is chlorine, for example, grey is carbon, white is sulfur. So that one, for example, is TNT. So yeah, so you can basically input your molecule, you'll get different colours, so you can sort of see a structural formula as you might see it on the chem or something like that.
That's ideas
Yeah, so this works for all sorts of things, like whether you want to put in something like orange, ethanoic acid, aka vinegar that you can eat, or you want to put in something like methylene, for example, or ketamine, they all work. Yeah.
Have we got glucose yet?
Should have got that.
Yeah. There we go. And so that's just generated glucose. And looks like we're out of time.
Yeah.
Thank you very much.
And it's work away. And we also do a little game here. So I'm going to tour recording first. So I'll start the game. And so you use an Excel drop down to choose which direction you want to move in. So if I go to the left and then click move, it will do that and give me the next piece. So I can go up here and do that. And I can just continue playing and merge my cells. So if I go up, I can get And this just keeps on going until you get 2048, which can take a very long time. And we also made Tetris and Flappy Bird. So if you look at some Tetris.
So it has a nice simple UI. You can it detects what cell you select it.
Hasn't been doing this.
I'm not.
Oh, I'm not quick. Okay. So this is user error.
Right. So it selects what cell you're selecting in the sheet and plays Tetris based on that. And it'll count up the number of rows that you managed to eliminate. You can rotate it, you can move it, it'll generate it randomly. Yeah.
You can win, but everything takes a while. I read that back. So the final game we made was Flappy Bird. And this one is like my favourite. This is like the special one because the others we did have to use like types of stuff. This is entirely done with formulas within Excel. No TypeScript, nothing extra. This is just Excel cells and a lot of formulas. So it works like you have a lot of clicking's going on because it's recalculating every time you click, but that's also the jump. So it's difficult to learn. There's a learning curve to it. But you can, I think our high score was maybe like 9. So you get multiple lives, but maybe, yeah. But yeah, so it's recalculating everything when you click, and obviously you click more quickly to jump higher. And then you can see, like, it's crazy the back-end sheet we have for this. So everything else is a bit easier. This is like, even like the clock has to be in here, and all the different calculations up there. And that's every possible height situation. And yeah, I mean, it works. Everything is entirely made in the Excel app, but Flappy is entirely made in
Here's an important part of that. A static file that simply tells you about compositing. However, GitHub really doesn't want you to make it non-static, and so that's perfectly what we have gone and done. It removes all JavaScript and a lot of CSS just by default when I get up README. It also removes a lot of useful HTML, like inputs. That's a real bummer. It also removes iframes, maps, pretty much anything you'd want to make an interactive program. So if we go here and we play as white, we've got the board state set up here. Nice little animation, very intended for loading in the game. And you can press on square to show you these moves that you can make. Reload, and then you can see here that we can, I'm just going to make a strange move, not preventing checkmate. And I've also got the Clyde for black set up here. And we actually can't cause a refresh to the opponent, which is unfortunate, so we've got a nice refresh button to refresh the screen. And here I've set up a checkmate so you can see how the game ends. So we're going to click queen. And actually, so that's a discovered check that I would have been, so actually I can't just say that. So instead I'm going to move the 9 in front of it. There you go. And then we're going to refresh on the screen. And make another stupid move not preventing checkmate. Because we want to be checkmated. And so the problem with this is, because it's a static file, you can't actually do any updating once the page is loaded, which means we need to do all of our computation in between the time when we start to refresh the page and when it finishes refreshing. And so that means what we do is we send
ping to the back end to redirect us back to the same page. And in between that time and when it's finished reloading, we do the chess computation, and then we actually commit back to the repository to update the images, and then it finishes reloading. And here we go. And we get a nice reset button to reset the game. GitHub is also a real pain in the ass because it has a proxy for all images, which means they all get cached. And so in that commit, we also have to invalidate the caches of all of the images by adding a new query parameter on it for the time. But there you go, that's GitHub chess.
Okay. Have you ever wanted to avoid texting your ex? Have you ever actually wanted to go to events on time? Have you ever wanted to save more money? Unfortunately, our app does none of that. Our alarm clock does everything you do not want it to do. We built the perfect alarm clock because it has no snooze button. You can only turn it off by walking. It randomly sends drunk text to anyone in your contacts. It reschedules the events in your calendar, not by a lot, but not that it will matter. And it buys ethical shares. Definitely not malware.
Okay, so for now, so we don't have to wait ages, we've just programmed this so that the alarm goes up immediately. So you select a random time, and you start the alarm. We won't bother you with the noise. We'll turn it off for now. So it's a message. It's also going to open up a WhatsApp in 17 seconds to deliver a random message, a drone message to one of the people. And it's totally hands off as well. So we'll wait for. Oh, it's inclusive. And you can see our text. We'll wait for it to send. But in the background, it's also changing our calendar events. So adjusting them by an hour forward or backwards. Also, the WhatsApp text, they send every minute, so you have to wait till the end of the minute for it to send, usually. Until then, we can also look at the calendar. So we can see that spoons, the event's been changed from 4 a.m. to 6 a.m. And that will send at some point as well. The only way to stop the alarm is to physically start walking. So while that's sending, we can show you how you stop the alarm. We can't move much, but if you move around, the steps will increase.
I don't know how far we can